Welcome, fellow trainees, to this masterclass explainer on CNC machining. Today, we're literally stepping right onto the shop floor to master the MATPC 501 standards. Look, if you're aiming to hit that RQF Level 5 benchmark, you are exactly in the right place. We're going to break down how to take raw materials and turn them into incredibly precise components, really focusing on the absolute foundations of parts production. Okay, let's just dive right in. The seamless, almost magical flow from a digital interface directly to physical cutting is exactly what we're here to master today. We aren't just pushing buttons here. We're translating computer-aided design into tangible, flawless metal and plastic parts. The operator at that control panel? Well, you're essentially acting as the conductor of a high-tech orchestra. To get us ready for the production floor, here's our quick blueprint for today. We'll start with a welcome to CNC machining, move on to decoding CNC terminology, then we'll look at the types of CNC machines, cover the manual setup process, and finish up the whole shebang with a final knowledge check.
Welcome to CNC machining. Let's get down to the absolute basics.
So the crucial takeaway here is that a CNC machine, which stands for Computer Numerical Control, completely replaces the old days of manual hand cranking. Instead of relying on human muscle and eyesight to guide a cutting tool, we use pre-programmed software to direct these massive machine tools. Whether we're carving out a block of metal, some tough industrial plastic, or wood, this automation is what gives us the ability to achieve a level of precision that a human hand simply couldn't replicate consistently. It's a real game changer.
Section 2, Decoding CNC Terminology. We've got to speak the language of the machines.
Every single great part we manufacture starts with a part program. Think of this as your master script. It's a series of highly specific coded instructions that the machine reads to actually do its job. Because let's be real, the machine doesn't have a brain of its own to decide how deep to cut or how fast to spin. It relies 100% on this part program to tell it every single micro movement it needs to make. Now, while the part program is the whole story, G-code and M-code are the individual words and letters. These specific programmed instructions control the motors and tools, guaranteeing that once we get the setup right, we can make the exact same part 1,000 times. And guess what? That 1,000th part will be perfectly identical to the very first one. That kind of repeatability is the true superpower of modern manufacturing.
Section 3, Types of CNC machines. Let's talk about the hardware.
Think about the setup of a milling machine. You have the spindle right at the top, which holds your cutting tool. In a mill, that spindle rotates the cutting tool at insanely high speeds and moves it down across the stationary work table where your raw material is clamped tightly in place. The machine travels along its guideways to literally carve out complex, multi-dimensional shapes from a solid block. Now, compare that to a completely different beast, the CNC lathe. In a lathe, you have a chuck. It operates by holding the raw material in that chuck and spinning the material itself at incredible speeds. Meanwhile, the cutting tools, which sit on a tool turret, remain stationary but slide along the guideway to peel away material from the spinning metal. It's so cool to see in action. Just to summarize that crucial difference, because this is something every trainee absolutely must get right. Mills move the spinning cutting tool around the material, while lathes spin the workpiece itself against a stationary tool. So, if you need to machine symmetrical, cylindrical parts, think long drive shafts, heavy-duty screws, or threaded bolts, the lathe is your go-to. But if you're carving a complex, boxy engine block, you're heading straight to the mill. Section 4, the manual setup process. Let's get into the practical application.
We're going to focus heavily on the manual tool setup process now, specifically the tool offset. And look, as an instructor stepping into the shoes of a floor manager right now, I have to warn you, while the concept of manual setup is incredibly straightforward, it is highly, highly prone to human error if you aren't focused. It takes time, it takes patience, and a single moment of distraction can lead to a crashed machine or a scrapped part. Focus here is literally everything.
So here's the exact 3-step manual procedure straight from your manual. Step 1, you carefully position the tool close to the workpiece surface along the Z-axis using the control panel. Step 2 is where your patience is really testing. You jog the tool down incredibly slowly. We're talking micro movements here. Step 3, you use a standard feeler gauge, or honestly often just a simple piece of paper, sliding it between the tool and the workpiece. The very millisecond you feel that tool pinch the paper, meaning it's finally made contact, you stop. That is your 0 point, and that's exactly when you set your tool offset in the machine control. Section 5, Final Knowledge Check. Time to see what's stuck. Okay, think back to that incredibly delicate process we just discussed with the piece of paper on the Z-axis. Why do we even bother going through all that trouble to zero out the coordinate system during setup? Take a second to lock in your answer. Well, if you answer that it's to ensure the machine knows exactly where to start cutting relative to your material, you hit the nail right on the head. Remember, the computer doesn't have eyes. Without setting that 0 point, the machine has absolutely no idea where the raw material is located in physical space. If you understand this, you're truly getting ready for the shop floor. As we wrap up this explainer, I want to leave you with this final thought. Automation is a powerful thing, but it's entirely dependent on and really only as good as the human setting the baseline. That multi-million-dollar machine relies on your piece of paper and your careful adjustments to know what to do. So as you head out to fully master these RQF Level 5 standards, ask yourself, how will you ensure perfect precision on your very next setup? Keep that focus sharp, and we'll see you in the next explainer.